Alright, how's it going there, pre-calc peeps? This is going to be video 2 in the series of graphing sine and cosine. First video, I just kind of showed you the basics. I showed you how to make a chart and make sine and cosine, and then I talked about what numbers had an effect on like amplitude and period. So now we're going to talk about graphing those things, taking into, here's the summary of that. Whether it says y equals a sine bx or y equals a cosine bx, a in front of sine and cosine is the amplitude, period. No no calculating, that's what it is. The periods of these functions are going to be 2 pi divided by b. So I have a couple of examples to start, and we'll see how many we do here, just to get the idea down, because there are some algebraic things that stress some students out. So anyway, here we go. This first graph, right away we see there's a 2 right out in front, amplitude's 2. So when I get ready to, I start drawing the graph almost. I go up to 2, down to -2, and I'm ready for my amplitude. Now this wasn't discussed a whole lot in the last video. This number, if you do, is the b. 2 pi divided by b is the period. So 2 pi divided by 3. That's the period number. Now what that means is this graph is going to end its sine cycle, at 2 pi over 3. Not at 2 pi, not at 1 pi. It's going to end there. Now the tricky part is dividing up the x-axis accordingly. There's going to be those are sort of evenly spaced. I'm just doing it by eye. Here's how I suggest you do. Now, if you have a way that works in your brain, you're like, I know how to divide this up, then do it. But here's what I'm gonna give you as advice. I'm going to start with this one that I wrote. This one is halfway to here. Here's 0 at the beginning. That's halfway to 2 pi over 3. Halfway to anything is multiplying by half, basically. So if I'm like, I need to calculate this. If you did 1/2 times 2 pi over 3, you'll get the label that belongs here. Now when you multiply, straight across top, straight across bottom, and then reduce. So on the top, 1 times 2 pi is 2 pi. 2 times 3 is 6. 2 over 6 reduces to 1/3. Or 1 pi over 3. So that label, 1 pi over 3. You look at it and say, oh, that makes sense. That's 1 pi over 3. That's 2 pi over 3. Twice as far. Next, I'll do this one because it's halfway to this one. So half of pi over 3 multiply 1 pi over 6. And that goes here. Now, for most students, this spot right here, which is going to be our final spot, is the toughest one for people to fill in. And here's how I teach it. And if you got a way to do it, then do it. But these are evenly spaced. So the very first mark here, even though it was the last mark I filled in so far, that establishes how far apart these are. Each one of these is pi over 6 apart because they're evenly spaced based on this space. Which means whatever's in the numerator, in this case it's a 1 pi. Count by 1 pi and say 6th. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. Now listen, I said 3 pi over 6. I'm just going to write that over here for visual. 3 over 6 reduces to 1/2, 1 pi over 2. And there are my labels. Now, again, think about this. 1 pi over 6, 2 pi over 6. 2 pi over 6 reduces, we did it already, to pi over 3. 3 pi over 6 reduces to pi over 2. And 4 pi over 6, 4/6, reduces to 2/3. There's your labels. Once you have your labels, draw a sine curve. Sine curve always goes from the 0 up on the first one, back to middle, all the way down, back to middle. And there's your sine curve with all the labels. Now, get a lot of students that are like, oh, this trigonometry stuff is difficult. It's not really the trigonometry that stresses people. It's this, dividing up the labels, and that's algebra. That's working with fractions, which is the real stressor to people. So, that's kind of the deal. Now understand something, and I said this last video. If this had said cosine, the only thing I would have done different is drawing the graph. Everything else would have been the same. Amplitude's the same, period's the same, dividing up the labels, the same. I would have started up here at the top, and then middle, then bottom, then middle, then top. We'd have that U-shaped looking cosine. Only difference, people. All right, let's go to this one. Threw in a few more fraction things to see how you handle that. So number 1, and I got a little more room to move over here. So we're going to get this graph ready to go over here. Right off the bat, I see that the amplitude is a half. Now what I normally do, I put a 1 right there and a -1 right there, and then I put the halves. And I know that's silly, but it just kind of gets me feeling like, hey, I cut it in half. Secondly, this number is the b value, which I'm going to use this formula to calculate the period, and this one's a little tricky for folks. It's 2 pi divided by b. 2 pi divided by 2/3. We've talked about this in other areas. We don't divide with fractions. We multiply with reciprocals. So this will change to 2 pi times 3 halves. You can put a 1 under here if you want to keep all organized. Folks, this multiplies to 6 pi over 2. Which gives me 3 pi. That is, see how this graph, it ended at 2 pi over 3? This one's going to end at 3 pi. Okay. We'll label these halfway to that. Now if you excuse me. If you know that, write it down. If not, calculate it. Half of 3 pi. That's like 3 pi over 1. That's 3 pi over 2. And some of you might look at that and say, well, of course, if you just cut that in half, it's divide by 2. Yeah. So 3 pi over 2. And then we'll fill in that one, which is halfway to that one. Half of 3 pi over 2 is 3 pi over 4. That goes here. Now this will give me an opportunity to maybe explain that counting thing a little bit better. See, like this numerator was 1 pi, so I went 1 pi, 2 pi, 3 pi, 4 pi, all over 6. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. This numerator on the counter, remember I got to get this one right here. The numerator's 3. I got to count by 3s. 3, 6, 9, 12. Fourths. So 3, 6, 9 fourths. 9 pi over 4. Now I always count the last one. Remember I said 3, 6, 9, 12 fourths? Folks, 12 over 4 is 3 pi. Go back to this one just so you can like, wait a minute. 3, 6. 6 pi over 4? 6 over 4 is 3 halves. There's your labels evenly spaced out. And I did use sine again. I kind of do that. Now I got to be careful that I stretch my graph out this way, but only go to an amplitude of a half. So start here, only half, here, only half low in here. So a lot flatter looking sine curve. So that's kind of the gist of it. I'm trying to think if there's anything else fancy about that, but that's kind of the gist of how you draw those sine graphs, working with the A's and the B's. I'm going to pause a minute, erase this, and maybe we'll just look at, at least one more to kind of just get the idea of a different period calculation just to see. Okay, couple more examples that I thought we should talk about because something that came to mind as I was erasing this and pausing this. Now, this one I already had set up that I was going to do, but there's one over here that's it's necessary that we talk about. All right, so let's go here. I did switch the two examples to be cosine just to give you the idea that I don't even pay attention to that till the end. So now starting here, there's nothing in front of that cosine. We understood it to be 1 or understand it to be 1. That means the amplitude's 1. So to get ready to draw this graph, got it going to 1 and -1, done. Okay, my B value is 5. Period is 2 pi divided by B. 2 pi divided by 5. That's a weird number, but we will deal with it. So right here, two pi divided by 5. First thing we'll do is halfway to that. Half of 2 pi over 5 starts out as 2 pi over 10, which reduces to 1/5. 1 pi over 5. That goes there. Halfway to pi over 5. Half of pi over 5 is 1 pi over 10. That goes there. And then we count. Now the counter this time is 1 pi in the numerator, so 1 pi, 2 pi, 3 pi, 4 pi, 10th. 1 pi over 10, 2 pi over 10, 3 pi over 10. Ending with 4 pi over 10. 4 over 10 reduces to 2/5. 2 pi over 5. We counted right. Always check that last one to make sure you count right. There's our labels. There's our amplitude. Folks, we got ourselves a cosine. That means we start here at the top. We go to the middle. We go to the bottom. We go to the middle. We finish on top. See? Only thing difference in the cosine is drawing the curve. They go through the same other calculations. All right, last graph for this video. The next section, the next video segment's going to talk about just tangent alone. So something looks weird in this one. I'll explain in a minute, but something that doesn't look weird. There's a 3 right in front of the cosine. Amplitude's 3. So that's all scaled for my amplitude. Now look at this B value. This is what I wanted to talk about. Listen, folks, the B is everything after the word cosine before the letter X. So B is 4 pi. Period is 2 pi divided by B. 2 pi divided by B. This B is 4 pi. Number 1, the pi's reduce. 2, 2/4 reduces to a half. Folks, this period doesn't even have a pi in it, and that's okay. It just means the graph ends at 1/2. And we divide accordingly. Now, many of you will just know off the top of your head, halfway to half is a quarter. As I said before, I like to be consistent. If you don't know, half of a half multiply 1/4. So there's 1/4. Halfway to a fourth, many of you would know it's an eighth. If you don't, and it's okay if you don't. Half of a quarter. Multiply 1/8. So that's this number. And again, you guys, I don't care what's in the numerator, it's what your increment is. So if your increment's 1 pi, it's 1 pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10. If it was like the first example, I'm trying to remember what that was right now. It was like 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. And then we had one where we had to count by threes. 3, 6, 9, 12 fourths. 3 pi over 12, 6 pi over, 4. 3 pi over 4, 6 pi over 4, 9 pi over 4, 12 pi over 4. This is a 1. Count by ones. 1, 2, 3, 4. Eighths. 1/8. 2 eighths. 3 eighths. 4 eighths. 4 eighths is a half. The count is on. Everything's labeled. We have an amplitude of 3. We have a cosine. We start at the top. Middle. Bottom. Middle. Top. And that ends that cosine graph. So that ends the segment on sine and cosine graphing, how to handle the amplitude, how to calculate the period, how to divide things up, which is really more algebra and fractions, your favorite, I know. But that's how that works. So that's the end of this particular section. The next one's going to be strictly about tangent. Take care, folks.